Your dealership just quoted you $2,500 for a total steering rack replacement, but they are hiding a massive secret. Your car isn't actually broken, it is trapped in a software lockout designed to drain your wallet. I'm going to show you how a 10-minute digital reset saves you thousands today. Imagine this scenario, which plays out thousands of times a day across the country. You walk out to your beloved Toyota Corolla, Camry, or RAV4 on a crisp, chilly morning. You turn the key, the engine cranks over slightly slower than usual, but finally roars to life. You shift into reverse, grab the steering wheel to back out of your driveway, and suddenly it feels like it is set in concrete. You physically cannot turn the wheel without exerting the strength of a professional weightlifter. You look down at your dashboard and see a glaring red steering wheel icon staring back at you. Panic sets in. You manage to wrestle the car to the dealership or have it towed, convinced that your steering system has catastrophically ripped itself apart. The service advisor takes your keys, disappears into the shop for an hour, and comes back with a grave expression. They tell you that the internal electric motor of your steering rack has suffered a fatal internal short, or that the torque sensor has completely sheared off its mounting. They slide a piece of paper across the desk demanding $2,500 for a complete electronic power steering rack replacement, plus an alignment, plus computer programming fees. You feel entirely helpless, completely at their mercy, because steering is a vital safety component. You authorize the massive repair, taking on crippling credit card debt, believing you had no other choice. But you did have a choice, because they lied to you. To understand the magnitude of this financial deception, we first have to travel back in time and look at exactly why Toyota changed the way their cars steer. And ironically, it all comes back to their obsessive quest to eliminate catastrophic engine leaks and blown seals. For decades, traditional power steering systems were entirely hydraulic. They relied on a massive, heavy, belt-driven power steering pump bolted directly to the side of the engine block. This pump would draw thick, red hydraulic fluid from a plastic reservoir and pressurize it to an astounding 1,000 to 1,500 pounds per square inch. This highly pressurized fluid was then forced down a series of metal hard lines and flexible rubber hoses into a complex rotary valve located on the steering rack itself. When you turned the steering wheel, this valve would open, directing that massive hydraulic pressure to one side of a sealed internal piston, literally using fluid dynamics to physically push the wheels left or right. It was a brilliant, robust system that provided excellent road feel, but it had one fatal flaw that haunted Toyota engineers and plagued owners for generations. It was a pressurized nightmare just waiting to leak. Because the system operated under such extreme pressure, the rubber seals were constantly subjected to immense thermal shock, chemical degradation, and friction. The high-pressure rubber hoses would slowly bake into brittle plastic from the radiant heat of the exhaust manifold. The internal rubber O-rings inside the steering pump would harden and shrink. Most devastatingly, the massive end seals on the steering rack itself, the critical barriers keeping that high-pressure fluid contained inside the metal housing, would inevitably blow out. When a hydraulic steering seal failed, it was never a subtle drip, it was a catastrophic, highly destructive event. A blown power steering pump seal would spray highly pressurized hydraulic fluid all over the engine bay, coating the drive belts, soaking the alternator, and shorting out its internal copper windings, and creating a terrifying smokescreen as the combustible fluid hit the hot exhaust headers. A blown steering rack seal would literally empty the entire fluid reservoir into the inner tie rod boots in a matter of seconds, leaving you with no steering assist while driving down the highway. Toyota owners were routinely spending thousands of dollars every 80,000 miles to replace blown hoses, leaking pumps, and ruptured steering racks simply because keeping fluids pressurized under the hood of a hot car is chemically and mechanically difficult. Toyota executives knew that if they wanted to maintain their legendary reputation for absolute reliability and zero engine bay leaks, they had to completely eliminate hydraulic fluid from the steering equation. They had to get rid of the pump, the hoses, the high-pressure fluid, and the vulnerable rubber seals entirely. This led to a massive engineering revolution in the mid-2000s, where Toyota aggressively transitioned almost their entire fleet to electronic power steering, or EPS. The concept was elegant and completely dry. Instead of a fluid pump on the engine, they bolted a powerful, high-torque, brushless electric motor directly to the steering column inside the cabin or directly onto a dry mechanical steering rack down below. When you turn the wheel, a highly sensitive magnetic torque sensor detects the exact rotational force and direction of your hands. It instantly sends a digital signal to a dedicated computer, the electronic power steering control unit. This computer calculates the vehicle speed, the steering angle, and your input force, and then instantly commands the electric motor to spin, providing seamless, silent mechanical assistance. No fluid, no high-pressure hoses, no pump, and most importantly, absolutely zero rubber seals to blow out and leak all over your engine. It was an engineering triumph that saved millions of gallons of hydraulic fluid and eradicated one of the most common sources of catastrophic leaks in automotive history. However, in solving a massive mechanical and sealing problem, Toyota inadvertently created a completely invisible, highly vulnerable digital trap. Because the new EPS system is entirely reliant on electronic sensors and software logic, it operates under very strict digital safety parameters. The steering computer needs to know exactly where the absolute center of the steering wheel is at all times. This precise mathematical center point is known as the zero-point calibration. It is the fundamental baseline the computer uses to calculate how much electrical current to send to the assist motor for a left turn versus a right turn. When your car rolls off the assembly line in Japan or Kentucky, this 0 point is permanently burned into the steering computer's memory. As long as the computer remembers where center is, the system works flawlessly. But here is the terrifying reality of modern vehicle architecture. That crucial memory relies on a steady, uninterrupted flow of electrical voltage from your vehicle's battery. Now, let us go back to that crisp, chilly morning we talked about at the beginning. You get into your car, and your battery is perhaps 4 or 5 years old. It is tired. The internal lead plates are heavily sulfated. When you twist the ignition key, the starter motor demands a massive surge of amperage to turn over the cold, thick engine oil. In that split second of heavy electrical draw, the overall voltage of your entire electrical system plummets from 12 volts down to perhaps 8 or 9 volts. The engine still manages to start, and the alternator immediately kicks on, bringing the voltage right back up to 14 volts. To you, it just felt like a slightly slow start. But to the highly sensitive microprocessors inside the electronic power steering control unit, that instantaneous micro drop in voltage was a catastrophic power failure. When the voltage dipped below the computer's minimum operating threshold, it triggered a momentary brownout. In that fraction of a second, the steering computer experienced digital amnesia. It completely forgot the 0-point calibration. It woke up from the voltage drop, looked at the steering angle sensor, and realized it had absolutely no idea where the center of the wheels was located. Now, if you are an automotive engineer programming a steering computer, and the computer suddenly loses its foundational safety calibration, what is the safest thing to do? You cannot guess where center is, because if you guess wrong, the electric motor might violently pull the steering wheel to the left or right while the driver is going 60 miles per hour. Therefore, the software logic is strictly programmed with a fail-safe protocol. If the 0-point calibration is lost, the computer intentionally disables the electric assist motor completely. It throws the red steering wheel light on your dashboard, logs a diagnostic trouble code like C1515 or C1525, which literally stands for torque sensor 0-point calibration undone, and shuts the entire system down to protect you from an unpredictable steering event. Your steering rack is not broken, your electric motor is completely fine, your torque sensor is perfectly intact. Your car simply suffered a microscopic voltage drop that erased a piece of software memory, and it is now sitting in a digitally induced coma to protect itself. This brings us to the dark, highly profitable underbelly of the dealership service network. When you tow your car into the service bay with a locked-up steering wheel, the technician plugs their expensive diagnostic scanner into the port under your dashboard. The scanner immediately pulls the code, indicating that the calibration is lost. Toyota Engineering specifically built a highly documented, incredibly simple relearn procedure into their factory service manuals precisely for this situation. They knew batteries would die, they knew voltage drops would happen, and they provided a method to simply tell the computer to relearn the center position. But performing a 10-minute calibration procedure does not pay the service advisor a massive commission, and it does not keep the service bays highly profitable. Instead of telling you the truth about the voltage drop and the lost memory, the dealership network has quietly weaponized this invisible software lockout. They look at the code, they look at you, and they intentionally misdiagnose the amnesia as a fatal hardware failure. They will claim the internal module is permanently fried, or that the torque sensor has lost internal continuity. They know that you cannot visually inspect the electrons inside a computer, and they use your fear of losing steering control to sell you a completely unnecessary $2,500 mechanical steering rack replacement. They will pull out your perfectly functioning factory rack, throw it in the scrap bin, bolt in a new one, program it, and send you on your way, heavily in debt for a repair you absolutely did not need. But you do not need their expensive scan tools, and you certainly do not need a new steering rack. You can force the computer to perform the zero-point calibration and completely restore your power steering right in your driveway using nothing more than a simple metal paperclip or a piece of speaker wire. This is the exact, step-by-step digital reset that the industry is desperate to hide from you. First, park your car on a completely flat, level surface. It is absolutely critical that the steering wheel is perfectly straight, dead center, and the tires are pointing perfectly forward. Turn the ignition completely off. Now, grab a flashlight and look under the driver's side of your dashboard, right above where your knees would be. You will see a white or black plastic rectangular plug with 16 tiny square holes in it. This is the OBD2 diagnostic port, the universal gateway into your car's digital nervous system. We are going to use a piece of metal wire to manually jump two specific pins in this port, bypassing the need for a $3,000 dealership computer. The pins are numbered 1 through 16. The top row is 1 through 8 from left to right, and the bottom row is 9 through 16 from left to right. We need to locate pin number 4, which is the main chassis ground, and pin number 12, which is the test signal pin for the steering computer. So, count from the top left corner, 1, 2, 3, 4. That is your ground. Then go to the bottom row and count from the left 9, 10, 11, 12. That is your test signal. Take your paperclip or a stripped piece of wire and bend it into a U shape. You are going to insert one end into pin 4 and the other end into pin 12. Now, sit up in the driver's seat and do not touch the steering wheel, the brake pedal, or the doors. Turn the ignition key to the on position. Do not start the engine, just turn it to the on position, where the dashboard lights up. You will immediately see the various warning lights on your dash begin to rapidly flash. This means you have successfully entered the factory diagnostic mode. Now, we have to perform the memory wipe sequence. With the ignition still on, you need to pull the wire out of pin 12 and then put it back in, pulling it out and putting it back in at least 4 times within an 8-second window. It is a rapid disconnect and reconnect sequence. Pull it out, push it in, out, in, out, in, out, in. When you do this correctly, you are physically interrupting the ground signal in a specific rhythm that tells the main computer to completely erase the corrupted steering angle memory. You will hear a slight chime, or the EPS light will change its flashing pattern. Once you have done the sequence, turn the ignition completely off. Take the paperclip completely out of the port. Now, we have to perform the final relearn. Put the paperclip back in, bridging pin 4 and pin 12 one more time. Make absolutely sure your steering wheel is dead center. Turn the ignition back to the on position. Do not start the engine. Wait exactly 1 minute. During this 60 seconds, the electronic power steering control unit wakes up, sees the test pins are jumped, realizes its memory is blank, and takes a permanent snapshot of the current steering angle sensor position. It locks that exact position in as the new permanent 0-point calibration. You will see the EPS light begin to flash in a steady, rapid rhythm, indicating the calibration is successful and locked in. Turn the ignition completely off. Remove the paperclip from the diagnostic port. Now, put your key in and start the engine normally. The red steering wheel light will extinguish, and the moment you touch the steering wheel, you will feel the immediate, smooth, effortless return of your electronic power assist. In less than 10 minutes, using a 2-cent piece of metal, you have outsmarted a multi-billion-dollar service network. You bypass their proprietary scan tools, you expose their predatory misdiagnosis, and you permanently restored your vehicle to factory specifications without turning a single wrench or opening a single mechanical seal. Understanding the history of why Toyota moved away from leaking hydraulic fluids and blown high pressure seals gives you the context to understand why this new electronic system exists, but knowing how to manipulate the digital software logic gives you the power to protect your wallet. Never let a service advisor condemn a modern electronic component without first ensuring the foundational software memory is intact. This simple paperclip trick is the ultimate defense against the modern automotive scam, proving that sometimes the most expensive mechanical failures are nothing more than a momentary digital illusion that you can fix for absolutely